already done synthesis and decomposition, single and double replacement, and all we have left is this little one called combustion. What is combustion? Well, let's look at a picture. It's fire. Yeah, you got it right. Combustion's pretty simple, pretty straightforward. Something burns, something oxidizes. Usually it's carbon and hydrogen, but it could be something like sulfur, some other things that burn. Usually it's elements like carbon and hydrogen together, something we call a hydrocarbon, like gasoline or wood. Other things like sulfur can oxidize, nitrogen can oxidize, and both of those would be things called combustion. So let's get to the rules. What's the rule for combustion? The rules for combustion are very, very simple. Something with carbon and hydrogen mixes with oxygen, you always make carbon dioxide and water. If we look at a balanced equation for it, this is the burning of methane, natural gas. If you notice, really what we're doing is oxidizing two elements. We're oxidizing the carbon from the methane here and turning it into carbon dioxide over here. Likewise, we're taking the hydrogen from the methane on the left-hand side and we're turning it into water on the right-hand side because it has been oxidized as well. That's it. It always makes carbon dioxide and water. Well, almost always. Sometimes things can incompletely combust, meaning maybe there's not enough oxygen to make the whole thing burn. Whenever you get something burning and there's not enough oxygen present, then you will produce some carbon dioxide, yes, but also some carbon monoxide. And it's impossible to write a balanced equation because you don't know how much of each one you're making. How do you know the difference between the two? How do you know the difference between incomplete and complete? This is how you know the difference. The Bunsen burner flame on the left is got a perfect balance of oxygen and gas because you're burning all the gas. It's a nice blue flame. The flame on the right is too much gas and not enough oxygen because that yellow is actually carbon that has not been burned. That carbon is soot particles, and those soot particles get excited. Their electrons jump up and jump back, and they give off this yellow light. So anytime you see a yellow flame, that's an incomplete combustion. So candle flames, fireplaces, and things like that tend to be incomplete combustion, and they're not really, really good because they give off carbon monoxide, which is poisonous. But if you went and looked at a gas stove or your grill that runs on gas, or if you looked at your home heating system that runs on gas, it's designed for the gas to come out in little tiny holes and to be surrounded by oxygen and air molecules to produce a blue flame. Your grill actually has a thing where you can adjust it. Maybe it's blowing itself out, or maybe it's producing a yellow flame, and it's a little slide cover that gives you more or less air, just like in a Bunsen burner. But complete combustion is blue, incomplete combustion is yellow. And that's it.